Because I told Michaela I would record it for her because she's not here today.
Michaela, we already did this, but we're starting over for you.
Yeah,
Welcome.
start over,
I better start over.
Number 1 is no quadrant, 450 degrees. Number 3, quadrant 3, negative 3 pi fourths. Number 5, quadrant 1, 13 pi 30ths. Number 7, quadrant 1, 15 degrees. Wonder how hard it's going to be to just listen instead of me writing all the answers. I should write all the answers. They're odd. You can check the back of the book, really, on the odds, right? Other questions on these? If some people had, in the nurse, I think, he didn't look so good. He didn't look very good. Mrs. Hodge saw him going into her class, and she said she thinks he's about to be done because his face was very flushed and he was mouth breathing.
He's just got to stay hydrated. He's doing just fine earlier.
What else did you have to do after this? 17 through 27? Odd? 17 through 27 are all on the no calculator. And again, these are odd. You can check in the back of the book. But you've got to be able to do these with either the unit circle or the triangles. I don't care which ones, but here you go. Ready for your answers?
Yep.
17 is 1/2. 19 is 1. 21 is 1/2. 23 is 2. 25 is -1. 27 is 0. Questions on those?
What was 25 again?
-1. So 270 degrees, remember that this is 180 degrees, so if you add 90 to that, that's 270 degrees. So ordered pair, that would be the point 0, -1. So cosecant is the reciprocal of
Sine.
sine, and sine is which coordinate?
X.
Y. So cosecant is the reciprocal of -1, and the reciprocal of -1 is just -1. So on the no calculator portion of the test, there are a ton of questions that there's not really a ton of work to show. For me, I draw a picture like this next to most of them because I don't draw a big giant unit circle to begin with. But if you have a big giant unit circle to begin with, you're just really looking at that to answer most of these questions. I'm kind of depends on the problem, but like if it was this problem, I would just draw it and I would label this, and then I'd write -1.
She's too smart for that.
I would if it was not on the axis. How about that? If it was like pi thirds, I'd draw the line and show the point, or draw the triangle. But I like to show my work. You also had to do 29 and 30, yes? 29 and 30 say use reference triangles and not your calculator. You don't have to use triangles, but you're not supposed to use your calculator. So again, triangles or unit circle are your choices. So 29, -pi6, you have two options. One option is you could just think about negative angles we measure backwards. So if we go backwards -pi6, is that on my unit circle? Yes. If you don't like dealing with negative angles, remember you could add 2 pi to that, and that would give you 11 pi 6. Either way, you end up right there. So unit circle people, you have to know the ordered pair for that. I know it's the same as pi 6 up here, which is square root of 3 over 2 1/2. But since I'm down here in quadrant 4, it's -1/2. And if you know the point, you're just supposed to give all 6 trig functions. So I can say the sine of -pi6 is -1/2, because it's the y value. And the cosine of -pi6 is square root of 3 over 2, because it's the x value. Tangent of -pi6 is y over x. But remember, the shortcut for this is don't stress about the fractions. The 2's will always cancel out. So you can just take the top of the y over the top of the x, which is -1 over the square root of 3. And I'm going to rationalize that. I don't care. You have to simplify fractions. I don't care. The book doesn't rationalize. I think you should, but I think you should. I think when you go to college and you take a math class, you're going to have a 120-year-old professor like I do that's going to rationalize the denominator. You might have a cool new hippie, hipster professor or hippie professor that doesn't make you rationalize, but it's nice to at least be aware of it, right? But I won't mark your own. Hippie, hipster. I was thinking of my department chair at ISU. That's kind of hippie. And she said you don't graduate. Lucas.
Just my fault, I asked a question. What was the question?
When you write sine, cosine, tangent, you have to put something here. So since they gave me the angle, I just put the angle there. If you want to say theta, you can put theta there. If you just say sine equals, that's wrong, and you're going to miss half a point. So don't do that. You're supposed to find all of them, right? So to find the other ones, we just flip it over. So cosecant of negative pi 6 is negative 2. Secant of negative pi 6 is 2 over the square root of 3, or 2 radical 3 over 3. And cotangent of negative pi 6 is negative radical 3. Brandon.
Did you use the triangle on this?
I didn't. I used the unit circle. But you could use a triangle.
How did you go about doing that?
Again, you have to know where you are. You have to know where negative pi 6 is.
Yeah.
And if you're going to use a triangle, remember that the reference angle should either be 30 degrees, 60 degrees, or 45 degrees. And since it's pi 6, that means that's 30 degrees.
Comes from the origin.
So then you just label your sides. You know the ratios are 1, 2, square root of 3. So the hypotenuse is 2. The shortest side across from 30 is 1, square root of 3. But again, you have to pay attention to where you are. Quadrant 4 means that's going to be a negative 1. And then you can do all the same things. Sine is opposite over hypotenuse, or negative 1/2. Cosine is square root of 3 over 2. Right? You get all the same values. You either draw the triangle or you know the point. I think it's about the same amount of work, but either way. 30 is, I don't really want to work 30 all the way out, but 30 is 19 pi fourths. That's way bigger than 2 pi, so you need to get back to an angle that you know. So again, if this was without a calculator, you got to make sure that you can subtract 2 pi without a calculator. Oh my gosh, we have to know how to do fractions. That would be 8 pi fourths, so 19 pi minus 8 pi is 11 pi fourths. Oh, that's still bigger than 2 pi. So do it again, and you get 3 pi fourths. That is going to be in your unit circle, or it's going to have a reference angle that is 30 degrees, 45 degrees, or 60 degrees. Fourths are my favorite, because what's the ordered pair of all the fourths? Test tomorrow, kids. Square root 2 over 2, square root 2 over 2. But in quadrant 2, which is where 3 pi fourths is, the x is negative. Or if you drew your triangle in, it would be 1, negative 1, square root of 2. Because of 45, 45, 90 triangle, 1, 1, square root of 2. And again, the x is negative. So sine would be square root of 2 over 2. Cosine would be negative square root of 2 over 2. Tangent would be negative 1. And then you just flip them all over for the other ones. But it's all about finding that point. Because 3 pi fourths means the reference angle is pi fourths, or 45 degrees. Fourths are 45 degrees. Sixths are 30 degrees. Thirds are 60 degrees. What'd you have to do next? 34? 33? 33 says find all 6 trig functions of this triangle. And again, you could do, this could be on either one, calculator or no calculator. You do some good old Pythagorean theorem. Good old Pythagoras. One time in high school, my teacher dressed up as Pythagoras for Halloween.
What does that look like?
He wore a toga and a beard. A sheet and a beard. No. Boys, are you ready for this test tomorrow? You just want to take it right now instead?
Yeah.
Zip it! Pythagorean theorem, right? I think you should get 13 there. I'm just going to tell you the answers. I'm not even writing them down. They say for this angle, so sine would be 5 over 13, cosine would be 12 over 13, tangent would be 5 over 12. Flip them all over for the other ones. What's the next one I make you do? Probably if I gave you one like 34, it's going to be more difficult than 34, because they say use a right triangle to determine the values of this. I would probably give you some other information like the ones we did where it says like if sine is positive, like I would probably give you something like this. Sine of theta is greater than 0, and cosine of theta is 5 over 7. Find all the other trig functions, right? Because I might make it somewhere else in the circle. Since they said use a right triangle, they're telling you it has to be positive sides. That would fit this also, because if sine is positive and cosine is positive, then that means we're in quadrant 1. So I could draw a little picture. Here's my angle. Cosine is adjacent over hypotenuse. So again, Pythagorean theorem to find this part. Again, if this was without a calculator, make sure you line the numbers up right. Make sure you subtract right. This is hypotenuse. So we'd say 7 squared equals 5 squared plus some side squared. So 49 equals 25 plus b squared minus 25. And we get b equals the square root of 24. Do I want you to leave it as a square root of 24?
No.
Do I want you to give me a decimal?
No.
No, I want you to simplify that and break that down into 2 square root of 6. Right? That goes right there. And again, if you can find the other side of the triangle, you can find where you are, what quadrant you're in, then you just list everything out. Sine would be 2 square root of 6 over 7. They already gave us cosine. Tangent would be 2 square root of 6 over 5. Flip them all over. Yes?
Three from there. On the other side, you take one.
True. I told you didn't have to do 36 and 37 because we haven't done those yet. So that's in the second half of chapter 4. Ow. No, I think you're in radian mode. But change that to degrees and it's probably right. What else do you have to do? 39 and 40? 39 and 42. 39 and 43. 43 you don't really know how to do yet either, so you can just skip that one. But 39 is going to be a question on your test. I mean, not this exact one, but you know, you get the idea. This would definitely be a calculator question because you got to have your calculator. And they give you some information. They're always going to give you 3 things. They give you angle C, and in 39, they also give you angle A as 35 degrees, and they give you side C is 15. So this is 35 degrees, this is 15. You have 3 things left to find, and right now for us, that's always going to be one angle and 2 sides. At the end of this chapter, you'll be able to do ones like 43, but not yet. So we need to find angle B, theta IV, and we need to find side A and side B. So 3 parts to this on your test tomorrow. So, not tomorrow, Thursday, because it's the calculator part. The easiest part is the angle. What do you know about the angles of a triangle? They add up to 180. So if you know 2 of the 3 sides, can you just subtract from 180?
Yep.
So I think it should be 55. Really, you just, because one of the angles is already 90, so that means the other 2 have to add up to 90, so I always just take 90 minus 35. Is that right? To find the other 2 sides, you have to use some trig, because you can't do Pythagorean theorem if you only know one side. I say use what they give you, so in case you made a mistake subtracting that you don't mess up. So I take the angle they give me, and if I want to find A, and I know this side, what trig function would I use? What trig function would be if I want this side over this side? Because opposite over adjacent would match this, right? It's not always sine. It's whatever it is that sets up the problem. So you have to look to see what it is. And on this one, I could say the sine of 35 degrees equals A over 15. And to solve for A, I'm just going to multiply by 15. Calculator, in degree mode, type it in, it gives you the answer. I think around to 1 decimal is what we usually do. Big thing on Thursday's test, which I'll remind you again tomorrow, and I'll remind you again Thursday, it's really important you're in the right mode. If you're in radian mode or degree mode for the whole time, if you don't switch as needed, you're going to miss a lot of points. 8.6. Technically speaking, now that I know side A, could I do Pythagorean theorem to find side B? I could, but I think setting up trig is easier and less work, because could I do the same thing that I did for A, only now use B and this side? So instead of using sine, what trig function would I use? Oh, you could use opposite over adjacent. I tend to stick with the ones that they give me in case I made a mistake. You see what I'm saying? Like, let's say I did this wrong. So now if I find B using wrong side A, But you're right. You could do tangent, and you could say this over this. I just am going to use cosine.
I prefer to be confident myself.
I can't subtract -1 minus -1 correctly sometimes, so I like to just use what they give me. And say that that would be b over 15, which means exact same problem, except for now I'm going to type in cosine of 35 degrees times 15, and I get 12.3. Really easy way to at least see if your answer is reasonable, especially if you're in radian mode. You'll probably know something's wrong because you'll get an answer like less than 1 probably. The biggest angle should be across from the biggest side, and the smallest angle should be across from the smallest side. So I always at least make sure that matches. 35 degrees is my smallest angle, and side A is my smallest side. The hypotenuse is the biggest. So at least my answer is reasonable, even if I made some calculation errors. Okay? So 43, you don't have to do. 45 through 48, I like those questions. You're going to have questions like that on your no calculated part of your test, and you're just looking at the ratios, like knowing whether it's X or Y they're talking about. So ready? I'm going to just go through the answers. 45 is quadrant 3, and then the rest are quadrant 2. 46 is quadrant 2, 47 is quadrant 2, 48 is quadrant 2.
You have the answers to 43.
Somewhere. There's in.
I have to go back to it.
We'll do one. Hold on. You just have to do inverse trig to find your angles. That's what we haven't done yet. On 43. Sorry. Like we haven't talked about that button on our calculator yet, so that's why you can't do it yet. But 43, really quick. 43, oh wait, hold on. Yeah, okay, sorry. 43, angle A is about, or alpha is like 44.42 degrees, and angle B is 45.58 degrees, and the side that's missing is about 4.9, it says, but 2 radical 6.
I used 4.9, wait.
So you could find the missing side on 43, but we haven't talked about how to find the missing angles. All right, so let's look at one of these. Which one, Brandon? All of them?
Let's go with 46. 42. Cosine of X.
For each one of these, what they give you can only be in one quadrant, because they're going to give you enough information that you could be able to tell me whether X is positive or negative and Y is positive or negative. If they tell me cosine is less than 0, which coordinate are they telling me is less than 0, X or Y?
X.
Because cosine is X. So this is the same as telling me X is less than 0. So if I'm thinking about my ordered pair, I know X is negative. Cosecant is the reciprocal of which one?
Sine.
So if cosecant is greater than 0, that's the same as saying sine is greater than 0. And sine is which ordered pair?
Y.
So this is telling me Y is greater than 0. What quadrant was the only quadrant where X is negative and Y is positive? 2. And you can do that on all of those. They can give you enough information to figure out what quadrant you're in. The trickiest one, I think, is tangent, because remember, tangent is Y over X, and you got to figure out which one is negative. Is it the Y that's negative, or the X that's negative, or like number 45, they tell you tangent's positive, but that could be quadrant 1, or that could be quadrant 3, because if they're both negative, then that's quadrant 3. And so, but the other ones, sine, cosine, secant, and cosecant, those correspond directly with whether X or Y is positive or negative. And so there's
47.
some of those on there. So we would say 2 on this one. On your test, we talked about this already once, but I'm going to remind you, when I ask you what quadrant, you have to write Roman numerals or I'm going to take points off. Okay? Roman numerals are how we write quadrants. Right? I'm not going to make you write this crazy nonsense.
I think so.
Right? We're not going to do that, but you do write quadrants as Roman numerals. So I want you to do that. Tangent X is less than 0. Sine is greater than 0. So if sine is greater than 0, Brandon, what do I know?
You know that it's positive.
What's positive?
Y part.
If tangent's less than 0,
Yeah, I don't know how to do that.
tangent's y over x, right? Well, we already know the y is positive. If tangent's less than 0 and the y is positive, what do you know x has to be? The only way that it can be negative is if x is negative. So what quadrant is negative x, positive y, still quadrant 2? Okay? That'll be on tomorrow's. I also gave you 49 and 50, and we talked about that yesterday. 49, you can check in the back of the book, so I'll do 50 if you want, but they're the same way. The biggest mistake that people make, like on 50, it says find the trig functions for the terminal ray that has an angle that passes through this point or whatever. The biggest mistake that people make is they're like, oh, sine is 7, cosine is 12, right? Because you think unit circle. 12, 7 is not on our unit circle, so you have to remember that you have to find r by doing Pythagorean theorem, or remembering that r is the square root of x squared plus y squared, which in this case would be 144 plus 49, which is not very pretty. Right? Is that right? And I don't think that breaks down any.
It's like 13 my fault.
Yeah, like there's no perfect squares in 193. So it's not pretty, but we can leave it like that. This is where you have to remember the ratios, that sine is y over r, cosine is x over r, or if you want, draw the picture. This is what Brandon asked me yesterday, how would I remember that sine is y over r? And I said, remember, you could just draw the picture. If x is at 12 and y is at 7, you can draw that triangle. It's a terrible triangle. But this will be 12, this will be 7, this will be the square root of 193, and you can just do SOHCAHTOA on that. But I just know that sine would be y over r, which would be 7 over the square root of 193, or 7 square root of 193 over 193. Does 7 go into 193? That's okay. Yeah, does it? If this was reducible, right, you can leave your radicals in the bottom, but if you can simplify your fraction, you still need to do that. So cosine would be 12 over square root of 193, or I'm just going to go ahead and rationalize my denominator. And tangent would be just 7 over 12, and then you can flip them over for the other ones. But remember, if it's not in the unit circle, that means the radius isn't necessarily 1. You have to find what r is in those problems. What else do we have to do? Something like that would be on the calculator. I don't know. I don't remember. I think that's on the calculator part. Is 95 the next one that you had to do? 95 and 96, story problems. Those would definitely be on the calculator part of the test because you have to draw a picture and you have to use your calculator. I guess you don't need a calculator to draw a picture. But you have to do a trig thing. 95 says the angle of elevation to the top of a building from a point 100 meters away from the building on level ground is 78 degrees. Find the height of the building. Oh, my building does not look like a right angle. 100 meters away, the angle of elevation. Angle of elevation means from the ground, and they say from the ground. Measuring up is 78 degrees. You're trying to find the height of the building, assuming that that is a right angle.
I thought it meant like the top of the building to where like the angle would be.
No. That's what I'm telling you. That's what I'm going over. Angle of elevation means the angle coming from the ground,
No, I mean
looking
like
at it.
100 was like the hypotenuse.
The angle of elevation of the top of a building from a point 100 meters away. No, I don't think so.
So like 100 meters away from the top of the building as well.
Right. No. I see what you're saying, but you gotta think like, in real life, if you were trying to estimate the height of a building, it would be much easier to count off 100 meters this way than to count this away, right? You see what I'm saying? So they're always measuring, almost always in these story problems, at least right now, they give you this horizontal distance when they're trying to find the height of something. You can even go ahead and set up 96. It's the exact same problem, except for we're talking about the height of a tree, right? And it says, a tree casts a shadow 51 feet long when the angle of elevation of the sun measured with the horizon is 25 degrees. So here's my shadow, and again, the shadow would be down here, would be 51 feet, and then the angle of elevation of the sun measured with the horizon, which means measured from the ground, is 25 degrees. It is. It's the same for both, meaning that we're trying to find this height given this angle and this side. So tangent would work on both of these. So say tangent of 78 degrees equals h over 100. Tangent of 25 degrees equals h over 50. one. They're not always tangent, but they tend to be tangent on these problems when you're looking for the height of something, because it seems like a lot of times they give you that horizontal distance. But it is confusing sometimes. So in section 4.8 is a whole section on story problems, and we'll talk about this a lot more then. But this is just a little preview. Again, in degree mode, you want to do this. So 100 times tangent of 78. You should get an answer of like 470.5 meters. Tangent of 25 times 51. It's like 23.8 feet tall, that tree is. Tomorrow we should have time after the test to kind of remind you of stuff that isn't on, like what isn't on tomorrow's test, you can assume is on the calculator test. Really smart thing to do, go back over that no calculator part of the quiz that we took. Stuff that we didn't talk about today, coterminal angles, reference angles, complements, supplements, right? Those are things that if it's not on tomorrow's test, will probably be on the calculator portion of the test on Thursday. So that quiz that we took earlier, this chapter is a really smart thing to study. Old worksheets, really great thing to study. But big thing for tomorrow, know your unit circle or know those reference triangles. Questions about any of that?
Yeah, I got a question.